Okay, today we will have a lecture on engineering mechanics. We will see in today's lectures the various concepts regarding engineering mechanics. We will try to cover the maximum things related with the engineering mechanics. As in today's lectures, we will have the concepts regarding engineering mechanics. So first, we will have the introduction for engineering mechanics. What are the different contents related with the engineering mechanics, which has been asked in the gate examinations. So we will have a short review of the various contents which has been covered related with the engineering mechanics. Here, what are the different contents related with this? So here, these are the different contents related with the engineering mechanics. So first of all, we will see the definitions of what is engineering mechanics, the system of forces which has been acting on a body. We will try to cover find out the free body diagrams, how to draw free body diagrams, what are the concepts regarded with the free body diagram. Next, we will see about the equilibrium equations also, the different forces which has been acting on our structures. We will try to cover the this related with the different types of forces which has been taken care. Next, again, we will see about the friction and its applications. Frictions plays an important role. So here, the frictions related part will also be covered. And finally, we will try to cover the center of mass. Where it has been taken care, for the point at which the lower mass is to be taken care, the center of mass will also be covered. Okay. Next is what is engineering mechanics? What is actually the definitions of engineering mechanics? So it is the branch of science in which it deals with the laws and principles of mechanics and their applications with engineering problems. That means when a forces are acting on a point, what are the different forces acting on a point? We have to find out when the forces acting on a point, when it is in static conditions, and the forces acting on a point when it is in moving conditions. You know, when the bodies are in static conditions, or when the body it is in moving conditions, the different forces acting on a body. So this is nothing but the that is mechanics and its applications with the engineering problems. Basically, engineering mechanics deals with the different types of forces which has been acting on a body. We have to first find out the different effect of that forces on a body, and to find out the reactions at the different supports, or the reactions, or find out the support reactions. Okay. Next is what is in the knowledge of the mechanics is very essential nowadays, because this engineering mechanics plays an important role. So it will be useful in various concerns. This engineering mechanics plays an important role. The knowledge of this mechanics is nowadays, it is very essential in nowadays. It has been used for planning works. It can be used for designing and constructions of various types of structures and machines. So this planning, designing, and construction totally deals with the mechanics. Okay. What is the physical phenomenon related with the mechanics? What are the different phenomenon related with the mechanics? Here, there may be a static as well as dynamic forces. We will see in detail what is a static and what is a dynamic. We will see in details. So here, fan which has been rotating at a constant speed. These are the examples for the mechanics when a fan that has been moving with a constant speed. So here, there may be some velocity will be there, some accelerations will be carried out. So this fan, it is having which is rotating at a constant speed, is the speed. It is nothing but the example of the mechanics. Blackboard sticking to the wall with the nails. It is again an example for the engineering mechanics. A body of a mass moving with a constant velocity. Any body which has been moving with a constant velocity can we can have an example of the mechanics. These are the examples of the mechanics. The examples for the sensible is nothing but the heat transfer from high temperature to the low temperatures when it has been transferred from one state to the another state, or it has been heat transferred from higher temperature to the lower temperatures. And sound, it is also an example of the mechanics. Okay. Next, again, we will firstly see the classifications of mechanics. We will find out, or we will have the classifications of engineering mechanics, or it has been classified into mechanics of solids and mechanics of fluids. Okay. So what is actually mechanics of solids? So mechanics of rigid bodies and mechanics of deformable bodies. Because solids, it has been divided into two. That is mechanics of rigid bodies, and next is mechanics of deformable bodies. We will see in details the rigid bodies as well as in deformable bodies. But what about the rigid bodies? So it has been divided into statics and dynamics. Okay. What is dynamics? Again, it has been divided into two. That is the kinematics and kinetics. Okay. The statics branch, it has been again divided into kinematics and kinetics. What about the deformable bodies? It has been divided into theory of elasticities and theory of plasticity. It is the advanced that is thing it has been covered. That is the theory of elasticity and theory of plasticity. Next is mechanics of fluids, ideal fluid, viscous fluid, and incompressible fluid. This it has been again a branch of engineering mechanics. So this will not be covered, but here this we will see about the statics, dynamics, and we will see about the kinematics and kinetics also. Next, according to the various classifications, we will cover, try to find out, we will try to cover the basics regarding the what is mechanics of deformable bodies. Okay. So the mechanics of a deformable bodies deals with how the forces it has been carried out. Okay, what are the different types of forces which has been carried out? What are the different types of forces which has been taken care? The mechanics of deformable bodies में क्या रहेगा? The mechanics of deformable bodies, it deals with how forces are distributed inside bodies and with the deformations caused by these internal forces. What are the different stresses which has been caused by the forces? Okay. What are the different stresses which has been carried out with the help of these forces? So this will be covered in the deformable bodies. Okay. So these internal forces produce stresses in the bodies, which could ultimately result in the failure of the material itself. Okay. So we will have the mechanics of deformable bodies. When forces are acting on a body, there may be change in the shape of the body. Okay? And there may be a change of shape in the body, though this is nothing but the deformable bodies. Okay? Next is what is mechanics of solid fluids. What is mechanics of fluid? So mechanics of fluid is nothing but the mechanics of fluid is a branch of mechanics that deals with the liquids or gases. Okay? So this again, it is again a branch of mechanics that is fluids, which deals with the liquids as well as the gaseous state. Okay? So fluids are commonly used in engineering applications. They can be classified as incompressible or compressible fluids are there. While all real fluids are compressible to some degrees, most liquids can be analyzed as incompressible in many engineering applications. Okay? So there may be compressible as well as the incompressible fluids also. Okay? But nowadays, we most of the fluids which has been classified as the incompressible. Okay? The study of the mechanics of the fluids, which will be studied in the courses which has fluid mechanics and compressible flow or hydraulics and others, will be studied in the different bit related with the mechanics. Okay. Next is what is mechanics of rigid bodies. What it deals mechanics of rigid bodies. Rigid body is a body which does not deform under the influence of force. When the forces are acting on a body, there is no as such effect of the forces on the body. Okay. So when there is no as such effect of the forces on the body, then body it has to be said as the rigid bodies. Okay? In all real applications, there is always deformations. There is always change in the shape of the bodies. However, many structures exhibit very small deformations under normal loading conditions, and rigid body mechanics can be used with sufficient accuracy in those cases. That means always there may be a deformation in the body because there may be changes in the shape or size of the body. So always the concept of deformable bodies will be considered. Okay. Next, we will see some basics fundamentals related with the engineering mechanics. The basic things related with the fundamentals related with the engineering mechanics. So number one is nothing but the length. because always the dimensions it has been measured, because length is the basic parameters which has been used for the calculations. So length is the quantity used to describe the position of a point in space related to the another point. That means the distance or the position of the 2 points can be measured in that can be identified with the help of length. Okay. The universally accepted standard unit for the length is the SI unit for this is nothing but the meters. What about this time? Next is number two is time. It is the interval between the two events when the distance or the interval between the two events. The generally expected standard unit of the time is it has been measured in seconds. So it is the interval between the two units. Space, the geometric region in which the study of a body is involved is called as space. The geometric region in which the study can be carried out, the study of the forces acting on a body can be taken care, is nothing but the space. What is displacement? It is defined as the distance moved by a body or a particle in the specified direction. That means the distance covered by the particles, which has been moved by a body or a particle in specific directions, it has been taken care as a. It can be taken as a displacement. Okay? Next is velocity. Velocity it is the rate of change of displacement with respect to time. That means rate of change of displacement with respect to time is nothing but the velocity. Next is what is accelerations. It is the rate of change of velocity with respect to time. Again, the acceleration is nothing but the velocity change of velocity with respect to time is nothing but the accelerations. Okay? Next is again important is momentum. What is momentum? Momentum is nothing but the product of mass and velocity is the product of mass and velocity is called as a momentum. ठीक है momentum क्या रहेगा? It is nothing but the product of mass and velocity. When mass it has been multiplied with the with velocity, it is nothing but the momentum. Okay. Continuum. A body consists of several matters is nothing but the continuum. Particles. What is a particle? A particle may be defined as an object which has only mass and it doesn't have any size. Is nothing but the particle. Okay? Such a body cannot exist theoretically. However, in dealing with problems involving distances that is considerably larger compared to the size of the body, the body can may be treated as a particle. Okay? Next is nowadays every it is having a vector as well as the scalar quantities. What is the vector quantities or what is the scalar quantities? Which is having magnitude as well as directions. And all the physical quantities, speed and force, are described as magnitude and a unit. So it will be considered. Vectors is also need to have its direction specified. That means it will have magnitude as well as directions is nothing but the vector quantities. Scalar is it doesn't have any directions. There is the direction it has been not taken care in case of the scalar quantities. Okay. So what is scalar quantity? Which doesn't have the directions is nothing but the scalar quantity. Whereas vector quantity is nothing but the it with specific directions is there. Okay. So displacement, velocity, accelerations, force can be stated as the vector quantities, whereas scalar quantities are mass, speed, distance, work, or energy. These are the examples of the scalar quantities. Okay. Distance it doesn't have any directions. Speed, mass, or work and energy. These are the examples of the scalar quantities. Next, these are the small example for the vector quantities. Suppose force, which is horizontal force, with 4 Newton it has been applied, which is moving right side, and 3 Newtons it has been moving vertically downwards. So what is the resultant vectors when we are joining this? So we can transfer this force, vertical force at right side. So here we can join this. The resultant vectors for this is nothing but the 5 Newtons. And the resultant vector for this case is nothing but the 5 Newtons. Next is we can have a small comparison of this. That means the comparison of mass and weight. So nowadays, these two are similar to each others, but there are the major difference between the mass and weight. So mass, it is nothing but a property of a matter. The mass of an object is the same everywhere. That means mass of a body is same everywhere. What about the weight? Weight, it is nothing but the depends on the effect of gravity, because and it will be different at the different locations. Okay? It will be changing when the locations or the changes. The weight of the body changes, whereas the mass, it remains same at every point. Mass can never be zero, but whereas weight can be zeros if no gravity acts. That means weight. The best example is in the space. The weight of a body in space is zero because there is gravity. Okay? Mass does not change according to the locations, whereas weight increases or decreases with the higher or lower gravity. The gravity increases, the weight of the body increases. The gravity decreases, the weight of the body decreases. So it will be dependent on the gravities. Okay? Whereas mass, it does not change according to the locations. Mass is a scalar quantities, whereas weight is a vector quantities, which is having magnitude as well as directions. Mass may be measured using an ordinary balance, but whereas weight can be measured with a spring balance. Okay? So, whereas what is the unit of weight? It has been measured in newtons, whereas mass, it can be measured in grams and kilograms. Okay? Next, we can have again basic differences related with the distance and displacement. The same sense, mass as well as weight. In the same sense, we can have the difference of distance and displacement also. Okay. So distance is the length of the path traveled by a body while moving from an initial positions to a final positions. It is just the length. Okay. What about the displacement? Displacement is the shortest distance between the initial position and the final positions. For example, we will see how to find out or how this displacement can be measured by a simple example or simple that is example. We can understand this how to find out the displacement of a that is the distance traveled by a body. Okay. So distance is a scalar quantities, whereas displacement is a vector quantities. Distance measured is actually it is a positive, whereas displacement can be positive or can be negative. Both the cases may be there. It may be positive or it may be negative. Okay. The total distance covered is equal to the algebraic sum of all the distances traveled in the different directions. When we can have the algebraic sum of the different distances, we can find out the total distance can be find out can with the help of by the algebraic sum of the distances traveled in different directions. What about the net displacement can be find out is the vector sum of the individual displacement in different directions. Okay. So individual displacement, with help of the individual displacement, we can find out the net displacement of any body. Okay. There is always a distance covered whenever there is a motions, whereas displacement will be zero if the body comes back to its initial positions. If the initial velocity is u or final velocity is v, and the distance if finally it comes back to its original position, that means the displacement taken by the body is zero. Okay. What about the units for both the cases? The units for both the cases is meters. So this is a small example for this when for which we can find out the displacement for this. Okay, now, and it has been moving in a zigzag way. So we can find out in a piece of a paper. We can find out by drawing a diagonal from this starting point to the end point. We can easily find out the shortest distance traveled by this end. Okay, now, the shortest distance traveled by this end is nothing but the displacement. Okay, now, displacement is nothing but the distance traveled by this end. Next is again there may be a simple comparison between the speed and velocities. The speed is refers to how fast an object is moving, whereas velocity refers to the rate at which an object changes its position. The rate of change of or displacement with respect to time is nothing but the velocities. Okay. Again, the speed it is it can be taken as a scalar quantities, and velocity it is having magnitude as well as directions. Therefore, it is a vector quantities. Okay. The speed is the rate of motions or the rate of change of positions, whereas velocity is the rate of change of displacement. Speed can be it can does the magnitude component of a velocities, whereas velocity contains both magnitude and directions. So these are again we can have some more differences for this speed and velocity. Again, the units for measurement, these are the simple conversions are used, which has been normally used for solving the problems. And these are the simple conversions which has been frequently used in solving the problems. The unit of measurement is the force unit is called as a Newton. That means it is defined as the force required to accelerate a mass of 1 kg. That means the force required to move or accelerate a mass of 1 kg at rate of 1 meter per second. That means we are moving a body which is having a mass of 1 kg at a rate of 1 meter per second. So what is the force required? The force is 1 Newton is equals to 1 kg. And what is acceleration? That is meter per second square, 1 meter per second square. So what will be the unit of force? 1 Newton is equals to 1 kg meter per second square. Okay, 1 kg meter per second square. Okay, just the multiplications is there. So kg meter per second square. So this way we can find out the unit of a force, that is 1 Newton is equals to 1 kg meter per second square. Okay. Again, we can have the unit of an object is the gravitational force which is exerted on that body or on that object, which causes it to accelerate downward at the acceleration due to gravity. So we can write for the weight of 1 kg mass, that is W is equals to weight is equals to mg, that is multiplied mass that has been multiplied with acceleration due to gravity. So here we are considering the mass as 1 kg, acceleration due to gravity we are considering as 9.807, that is 9.81 or 9.807 meter per second. So what is the weight of the body? Which depends upon the that is the accelerations, gravity, acceleration due to gravity. So here it can be W is equals to weight of a body can be taken as 9.807 newtons. Okay. These are the basics regarding the SI prefixes which has been used while solving the numericals related with the engineering mechanics. Okay. Next is most important are the which are the different fundamental laws which has been considered or in mechanics. Okay? These are the most important laws or the fundamental laws which has been considered in engineering mechanics. So what is Newton's first law? An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same directions unless acted upon by an unbalanced force. That means unless an external force is acting, it cannot change the state of a body. It cannot. That means the state of body. That means when the body is moving. When the body is at its motion, it will always be in motion unless an external force it has been acted. Okay? Or when the body is it is in rest, so it will be in rest unless an external force it has been acted. Okay? This law is often called as the law of inertia also, or Newton's first law also. Objects tends to keep on going what they are doing. In fact, it is the natural tendency of an object to resist change in the state of motion. That means it is a natural tendency of a body. That means it doesn't change the state of the motion. Okay? That means the state of the body remains same unless the action on force it has been active. Okay? This tendency to resist change in their state of motion is described as inertia. Inertia is nothing but the tendency to resist any change in the state taken is nothing but the inertia. These are the basic example for this. And a vehicle that has been moving in forward directions, small force it has been active. So this when we are changing a state from kinetic motions to kinetic energy to the potential energy, so this will result a small. That is the example for the Newton's first law. Okay? Next is what is Newton's second law? The rate of change of momentum is directly proportional to the inverse force, and it takes place in the direction of the force acting on it. That means rate of change of momentum is directly proportional to the force, and it takes place in the directions of the force acting on it. That means F is equals to mass into accelerations. F is equals to mass into acceleration. This force is directly proportional to rate of change of momentum. That means what is momentum? Momentum is nothing but the mass into velocities. As mass do not change, therefore force is equals to just we are change mass into what is velocity, rate of change of velocity. Therefore, force is directly proportional to mass into accelerations. That means force is directly proportional to mass into accelerations. This is nothing but the example for this Newton's second law, that is force is equals to mass into accelerations. That means when a force, depending upon the weight taken, a force is equals to mass into acceleration. That means depending upon the mass which has been taken. There is a simple example there. There is a loading cart is there, a trolley is there. When there is mass, it has been less. The small acceleration will be more. The mass increases, acceleration will be decreases. And again, the mass more mass will be added. The acceleration will increase when a large force is exerted. Okay? So these are the simple examples for there is the Newton's second law. Okay? This is a simple example for the Newton's second law. Next is these are the example for the Newton's third law. What is Newton's third law? Every action it is having an equal and opposite reaction. That means every action it is being having an equal and opposite reactions. That means here there is a swimming pool is there. When we are exerting a force, that means yeah, there is an upward and downward force which has been exerted due to this horizontal surface, okay, na? Cantilever surface. Okay? So every force it is having equal and opposite reactions. This is the best example for the Newton's third law. Okay? Again, while the swimmer which has been moving in that is in forward directions, again the force which has been acting in action, it has been moving in reverse directions also. Okay? Next is Newton's law of gravity, gravitations. How Newton's law of gravitations, when the two masses are there, m1 and m2 are the two different masses which has been separated by the distance. So every body attracts the other body. The force of attractions between any two bodies is directly proportional to the masses. It has been directly proportional to the masses and inversely proportional to the square of the distance between them. Okay? That means it is directly proportional to the masses and inversely proportional to the square of the distance between them. ठीक है ना? F is directly proportional to m1 m2 divided by d square. ठीक है ना? These are the two circular bodies are there which is having m1 and m2 are the two masses. And when a different it has been separated by distance and towards the point when a force it has been acting towards the point. So what is Newton's law of gravitation? The F is equals to that is g is m1 m2 divided by d square, where g is the constant of proportionalities and is known as the constant of gravity. ठीक है ना? This is nothing but the constant of gravity. Next is what is the principle or law of transmissibility of forces. ठीक है ना? What is transmissibility of forces? This is a simple body is there, the state of rest or of uniform motions of rigid body is unaltered if the point of applications of the forces is transmitted to any other point. That means there is no as such effect when the point of application that has been transferred from one point to other point. That means these are the 2 points are there. Point A is there and point B is there. So we are transferring or transmitting force from this point A to point B without any change in effect. Without any change in effect, okay? There will not be any change in effect of the forces. Okay? But it should be transferred along the same line of action. It should be transferred along the same line of actions. Okay? Now, one thing that has to be taken care. It should be transferred along the same line of actions. Okay? So this is nothing but the principle of transmissibilities. Okay? Next is what is law of superpositions? Law of superposition, law of transmissibility of forces can be proved using the law of superpositions. That is, which can be stated as the action of a given system of forces on a rigid body is not changed by adding or subtracting. That means when we are adding some forces or when we are subtracting the forces, the effect of the force on a body will not be changed. Okay? When we are adding or subtracting the forces, this is nothing but the law of superposition of forces. Okay? So what it states, the action of a given system of force on a rigid body is not changed by adding or subtracting another system of forces in equilibrium. Okay? When a force is it has been added or subtracted. Okay? So this is the example for this. Force F, it has been acting at point A, but here at point B we are applying two different forces. That is away from the point. These are the two forces. There is no as such effect of these two forces on the point B. Okay? So here just we are transferring from A to point B. Okay, by principle of transmissibility, and there is no effect of these two forces on the body. Okay? This is nothing but the law of superpositions. Next is what is law of parallelogram law of forces. So parallelogram law of forces क्या रहेगा? When two different forces are acting, ठीक है ना? If two forces acting simultaneously on a body at a point are presented in magnitude and directions by the two adjacent sides, ठीक है? Of a parallelogram. That means we are representing with the two sides of a parallelogram. ठीक है? So magnitude and directions. ठीक है ना? On a body at a point are presented in magnitude and directions but two adjacent sides of parallelogram. The resultant is represented in magnitude and directions by the diagonal. That means with the help of these two sides, the parallelogram sides of the parallelogram, we are representing the forces by the two sides of a parallelogram. That means the resultant will be taken by the diagonal sides. ठीक है ना? Diagonal sides will represent the resultant. Diagonal of the parallelogram will represent the resultant of this. ठीक है ना? The diagonal of the parallelogram which was passes to the point of intersection of the two sides representing the forces. ठीक है? So here the horizontal force is F1 is 4 units. That means 4 newtons is there. Whereas F2 is 3 newtons. We can find out the resultant for this when the angle made by these two forces is theta, whereas the angle made by this resultant with horizontal is alpha. Angle made by this resultant with horizontal is alpha, whereas angle made by these two forces, that is F1 and F2, is theta. ठीक है ना? These are represented by the two sides of a parallelogram. ठीक है ना? The 4 meters and 3 meters. These are the two sides of the parallelogram. ठीक है? Next is how we can derive the different laws. Again, the triangle law of forces may be stated as if two forces acting on a body are represented one after another by the sides of triangles. Same way we have seen law of parallelogram. The same way triangle law of forces is there when it has been represented by the sides of our triangles. And when the two forces are represented by the sides of the triangles, if the two forces acting on a body are represented after another by the sides of a triangle, the resultant is represented by the closing side of the triangle. This term is very important, which has the resultant will be represented by the closing side of the triangles. Taken from the first point to the last point. Next is what is a polygon of law of forces. If a number of concurrent forces acting simultaneously on a body are represented in magnitude and directions when different concurrent forces are acting. ठीक है ना? Different concurrent forces are acting in magnitude and direction by the sides of polygon. Taken in order, then the resultant is represented in magnitude and directions by the closing side of the polygon. ठीक है ना? Which can be represented by the that is closing side of the polygon, then from the first point to the last point. Okay? This is nothing but the polygon law of the forces. Yeah. Next important is classifications of mechanics of rigid bodies. Okay? Classifications of the mechanics of the rigid body. Okay? Classifications of the mechanics of the rigid bodies. Okay? How it can be represented, the mechanics of rigid bodies we can define as statics as well as dynamics, whereas dynamics can be divided into kinematics and kinetics. ठीक है ना? So here we will see what is statics. Statics is the branch of the mechanics which deals with the particles and bodies at rest. When the different forces are acting on a body when it is at rest, it can be considered under the statics. ठीक है? Dynamics में क्या होगा? It is the branch of mechanics which deals with the particles and bodies in motions. But again, it has been divided as kinematics and kinetics. Kinematics में without considering the force causing the motions, whereas in kinetics with force causing the motions. By considering the effect of force causing the motions in kinetics, we will consider the force causing the motions, whereas in kinematics, without considering the force causing the motions. Okay. Again, what is a force? According to the Newton's first law, force is defined as an action or the agent which changes or tends to change the state of rest. Force करेगा, it results in changes or it tends to change the state of rest, ठीक है ना? Or of uniform motion of a body in a straight line, ठीक है? Next is what is the unit of force? In MKS unit, it has been taken as kgf, whereas as a unit for the forces in newtons. The 1 kgf is equals to g, that is 9.81, that is meter per second square. That means 1 kgf or 1 kg is equals to 9.81 newtons, or approximately it has been taken as 10 newtons. The 1 kgf is equals to that is equals to 10 newtons. Next is what are the characteristics of forces? ठीक है ना? How we can what are the different characteristics of forces? How we can identify a force, on the what basis it can be identified? ठीक है ना? So number one, it can be identified with the help of magnitude. ठीक है ना? It can be denoted by 10 kgs of or 100 newtons. So force can be characterized, find out with the help of the magnitude. Next, it can be taken care by the point of applications where it has been acting. ठीक है ना? Force can be acting at a point. ठीक है ना? What is the point of applications? So it indicates the point on the bodies on which the force it acts. Line of actions. The arrowhead placed on the line representing the direction represents it. That means the arrowhead represents the line of actions of the force, whereas direction क्या रहेगा? It is represented by a coordinate or cardinal systems. With the help of the coordinates or with the help of the x and y coordinates, we can find out the direction of force. Okay? So the force can be represented with the help of magnitude, that is the characteristics, point of applications, line of actions, and the directions. Okay? Here is the simple example in which there is a ladder which has been placed on a vertical wall, and there is a horizontal floor is there and vertical wall is there, and there is a point load or a load it has been applied which is having 600 newtons, which is a load it has been applied on a ladder which has been resting on point A and B. So at a vertical support there is a point B, and at a horizontal support there is a point A, and which is there is a man or there is a weight which is having a 600 newton. So this 600 newton represents the magnitude, whereas this point it has been is nothing but the directions, vertically downward directions. The direction is vertically downward. The line of action is from C to D. It is moving. This dotted portion indicates the line of action of a force which has been moving from point C to point D. What is the point of applications for this? So point of applications is point C is the point of application for this. Okay. The magnet of force is written near the arrows. These are the things which has been taken care. This is a simple example which has been considered for a force which has been acting on a ladder, okay, na? Which has been resting on a floor and which has been resting on a vertical wall. These are the important things which has been considered. That is the classifications of forces, of force systems. There is coplanar force systems, non-coplanar force systems. Coplanar can be divided into two, again concurrent and non-concurrent coplanar forces, whereas it can be divided into collinear or non-collinear forces, parallel and non-parallel forces. Again, parallel and non-parallel forces can be divided into like and unlike parallel forces. So these are the force system, different in coplanar and non-coplanar. We will study with the help of a simple example the different force system. There is coplanar or non-coplanar or concurrent forces. We will see with the help of the simple example these things. Collinear forces, the line of action of all the forces acting along the same line, it is nothing but the collinear forces. When the different forces which has been acting on same line is nothing but the collinear forces. Okay. What is the example for this? Tug of war, or that is the example. The rope of a tug of war is the simple example for the collinear forces when the forces are acting on the same line. Okay. Next is what is the example for the coplanar parallel forces? Coplanar, all the forces are parallel to each others and lies in single plane. Okay? When the different parallel forces are acting on a body and which is along the same plane is nothing but the coplanar parallel forces. Okay? For example for this system of forces acting on a beam subjected to vertical load, that means the different forces which has been acting on a beam. Okay? Coplanar like parallel forces, all forces are parallel to each other's, lies in a single plane and are acting in the same directions. ठीक है ना? That means they are parallel to each other's and they are along the same plane, coplanar and parallel forces. The weight of a stationary train on a rail when the track is straight, that means this is example for the coplanar parallel forces. The different forces are acting when a moving train, it is a stationary train is there on a track, on straight track. So this is example of a coplanar parallel forces. Next is coplanar concurrent forces. A line of action of all forces passes through a single point and forces lies in the same plane. Forces on a rod resting against a wall is the example for the coplanar concurrent forces. Next is coplanar non-concurrent forces. All forces do not meet at a point but lies in a single plane. That means they when on the same plane coplanar, but they are non-concurrent to each other. Okay. Forces on a ladder resting against a wall when a person stands on a run which is not at a center of a gravity. That means at some distance, which has been at some distance, it has been when it has been standing on a ladder. It is the example of the coplanar non-concurrent forces. Okay. Non-coplanar parallel forces. All the forces are parallel to each other, but not in same plane. These are the examples for the weight of a bench in the classroom. Again, non-coplanar concurrent forces, for example, is nothing but the tripod carrying a camera. Non-coplanar non-concurrent forces, the example for this is nothing but the forces acting on a moving bus. These are the few figures for this coplanar concurrent forces, coplanar non-concurrent forces, collinear or coplanar non-collinear forces, coplanar parallel forces along the same plane. The different parallel forces are there. Coplanar like parallel forces when all the forces are moving in downward directions. Non-coplanar parallel forces, non-coplanar concurrent forces, and non-coplanar non-concurrent forces. So these are the examples for this. Next is most important is next bit is resolution of forces. ठीक है ना? So we will resolve the two forces into a single force. The resolution of forces is very important. Resolving, or what is the effect of this two forces? We are resolving this single force when a force which has been acting at some distance when in it is not acting in horizontal or in vertical, and this force it is making an angle of theta with vertical or with horizontal, which in present case this force it has been making an angle with horizontal. So it is when it is been acting in at some distance from this. So we will find out the effect of this inclined force. The effect of this inclined force along x and y directions will be same. That means the addition of these two forces will be same as the effect of this single force F. Okay? So it is the often convenient to split a single force into two. That is perpendicular components. That is horizontal component and vertical component. Fh is the horizontal component. Fv is the vertical component. So just we are finding out by using the simple trigonometry sin theta cos theta concept. So what is sin theta? Sin theta is nothing but the opposite upon adjacent. Okay? Now here opposite side is vertical side. Fv is the opposite side. What about the hypotenuse? Here vertical force F, inclined force capital F is the hypotenuse. Okay? So Fv is it has been taken as F sin theta. What about the cos theta? Fh it has been taken as the F cos theta. Okay? So by simple resolving this inclined force into two components, that is the horizontal and vertical components, we can easily find out the effect of this inclined force with respect to horizontal and vertical axis. Okay? Again, by changing the quadrants, we can easily different in different quadrants. We can find out the effect of these forces in first, second, third force. This is nothing but the example for the first quadrant. Okay, when the horizontal force, when the inclined force, it has been making an angle of theta with vertical. When it has been making an angle of theta with vertical, that means vertical component will be cos theta, ठीक है ना, f cos theta, whereas horizontal component will be sin theta, ठीक है ना, f sin theta. What about this third quadrant? In third quadrant, when the force it has been acting and it has been making an angle of theta with vertical, it is making an angle with vertical, तो क्या होगा यहाँ पे f cos theta and other component will be f sin theta, ठीक है. So depending upon the angle made by the force when it has been making with horizontal component or horizontal x-axis or vertical y-axis, ठीक है. So depending upon this, it may be a cos theta when it has been making an angle with vertical. The vertical component will be cos theta. When it has been making an angle with horizontal, so horizontal component will be cos theta. Again, this is nothing but how to find out the resultant of the forces when the different forces are acting. So resultant can be find out f is equals to square root of that is horizontal fx square plus fs square. That means summation of all horizontal forces plus summation of all vertical forces. Square of the summation of all horizontal forces plus summation of all vertical forces. How to find out the angle made by this resultant? So theta can be find out theta is equals to tan inverse of y by x. Okay. The y component is f2 and x component is f1. Therefore, f2 upon fy. That is nothing but equals to vertical upon horizontal component. That is equals to vertical upon horizontal component. This can be written as vertical as well as horizontal components. And here we can resolving the forces around the edges of the inclined quadrants. When the forces are acting on an inclined plane, how to resolve the forces when when the forces are acting on inclined plane. Okay, so there is a plane with inclined plane is there, which is making an angle of theta with horizontal. So resolving 2D forces on inclined plane equivalent to 1D force along and perpendicular plane. That means if a force which has been acting vertically downwards, so this theta, which has been making this inclined plane, it has been making an angle of theta with horizontal. This theta will be transferred at this. It will make with vertical axis. You know, vertical axis. It will angle made with the vertical axis. That means this theta will be transferred here. That means this component will be f cos theta and the remaining component will be f sin theta. So this transfer of this theta when the angle made by this inclined plane is theta, and transfer of this theta, it is along the vertical axis is very important. How to transfer this theta here from this point to this point is very important. When we are drawing a perpendicular to this, so this theta with when it has been making with horizontal will be transferred here at this point. So this will be f cos theta and this remaining side will be f sin theta. Next is representations of forces when the different forces are acting. If horizontally right side force it has been acting, we will consider it as positive plus in positive directions. So it will be considered as positive when it has been moving right side. So F is equals to 10 Newton when it has been moving right side. When it is moving vertically upwards, so 10 newtons when it is moving vertically upwards. Whereas when the angle made by this horizontal with horizontal theta is there, again by resolving this, again it is moving towards right. Therefore, plus sign will be taken. Okay? Again for this force, when it has been moving left side, so this will be minus sign. Because of the minus sign will it will be taken. So this will be taken as minus sign because it is moving left side. Okay? So here this is the simple sign conventions which will be used while solving the numericals. Right side will be taken as positive, left side will be taken as negative, upside will be taken as positive, whereas downward directions will be taken as negative. Okay? Next is this concept is again very important. 3D concept is again will be considered. The 3D forces may when inclined force F is acting, but along X, Y, and Z. Third three-dimensional figure is there. When the three-dimensional figure is there, on a force it has been force F it has been acting. Angle made by this force with horizontal x-axis is theta x. Angle made by this force with vertical y-axis is theta y. Whereas angle made by this force with the z-axis is theta z. ठीक है ना? Angle made by this force with the z-axis is theta z. ठीक है? So that means this force it has been acting on a body. We will try to find out the effect of this force, the 3D force effect of this force along x, y, and z directions. Okay? So every component for this is cos theta x, cos theta y, and cos theta z. Okay? Directions along L, M, and N directions. Okay? So F is equals to F cos theta, theta x along I directions, I vectors F cos theta y along J directions, and F cos theta z along K directions. Okay? So here with help of this we can find out the effect of this along the three directions along X, Y, and Z directions. Okay? So effect of the forces along X, Y, and Z direction. The 3D figure is there. Okay? So F is equals to F cos theta x along I directions, F cos theta y along J directions, and F cos theta z along that is K directions. Next important is condition of equilibrium is again important. When the different forces are acting on a body, the effect of the force is zero. That means there is no as such effect of the forces on a body. Okay? The body is in equilibrium. What is the effect of the forces on a body is zero. That means body is in equilibrium condition. That means summation of all horizontal forces is zero. Summation of all that is vertical forces in along y directions is zero, and along z direction summation of all forces along z directions is also zero. Okay? That means the body is at rest. There is no effect of that forces along x, y, and z directions. Okay? The body is in equilibrium. Okay? So after resolving the forces, apply equilibrium equations. That means these are the different example is there. Simple example is there in which we the different forces are acting. F1 and F3 they are moving in right side directions. F4 it is moving in upside directions. F5 it has been moving in downward directions. F6 is also moving in downward directions, and F2 it has been moving in left side directions. Again, so how to find out the effect of this all forces? So first we will resolve this in along x and y directions. Okay, so F1 is moving right side, so plus F1. F3 is also right side plus F3. What about F2 is moving left side, so minus F2. Okay, minus will be there. Minus F2 is there. That is equals to 0. Along again along y directions, F4 it has been moving in vertically upside direction upward directions. So it is plus F4 minus F5y, because F5 it has been moving in vertically downward directions, whereas F6 is also moving in downward directions. So minus F6 is equal to 0. So this way we can find out the effect of forces. ठीक है ना? Effect of forces on a body in different directions. ठीक है ना? In vertically upward directions or downward or right side or left side directions. So in this way we can easily calculate the magnitude, or we can find out the effect of forces in different directions. ठीक है ना? Effect of forces on a body in different directions. Next is what is free body diagrams. ठीक है ना? What is free body diagrams? Showing the magnitude and directions or directions of the various forces on a body, including the weight of the body. When what is free body diagrams? When we are removing the supports. ठीक है ना? Here the string it has been, there is a weight which has been applied, or these are the two strings which has been attached at point A and B. But after removing from this support, there a tension will be created here. ठीक है ना? तो फ्रॉम after removing this from the support, the tension end में क्या होगा यहाँ पे? तो we will call this as OA. T is the tension created at this point, so T OA. T stands for tension, so T at the point OA. Whereas when we are cutting from, at this point also, तो क्या बनेगा यहाँ पे? T T, that is OB. Angles are same, so theta 1 and theta 2, this angle will be the same, and this it is weight is moving vertically downwards. So here W it will be moving in vertically downwards. So this, after removing from the supports, the diagram, it is nothing but the free body diagrams. After removing the figure, the diagram from the different supports, here we have removed this TOA. It has been created here, TOB, which is making an angle of theta 1, TOA, it is making an angle of theta 2, and weight, it has been moving vertically downwards. Okay. Here we can, by the conditions of equilibrium, we can easily solve this problem. We can find out the forces in these methods. Again, the principle of transmissibilities we have already covered in previous slide. Here, these are the example for this, simple example for this. When a force, it has been transferred here, we can, at the same point, we can transfer this force at the same point also. Okay, na? So here this force can also be transferred here. Principle, by the principle of transmissibilities. Okay. Next important concept related with this is Lami's theorem, which has been which has been used to solve the unknowns or the different forces in our body by the Lami's theorem. Also, we can use this Lami's theorem also when the three different forces are acting on a body. Okay, na? These are the P, Q, and R. PQR and are the forces which has been acting on a body. So these are the coplanar forces. When the three different forces are acting on a body, which has been away from the point. These all forces are, while using this Lami's theorem, these forces should be away from the point. Okay. If three forces acting at a point, the ratios of each force to sine of its opposite angle are equal. Okay. That means P, that is directly proportional to sine of angle of the opposite two forces is sine of alpha, whereas Q is directly proportional to sine of beta, whereas R is directly proportional to sine of gamma. Okay. That means sine of force and the sine of angle made by the opposite of the two forces. Okay. So P is directly proportional to sine of angle of the opposite two forces, the angle made by the sine, that is sine alpha, whereas Q is sine beta, directly proportional to sine beta, and R is directly proportional to sine gamma. That means simplified way में क्या होगा, the P upon sine of alpha, that is equals to Q upon sine of beta, that is equals to R upon sine of gamma. Again, this concept is very important. That is the condition of equilibrium in 3D, 2D. Okay. These are the different forces which has been acting on a body. F1, F2, F3, and F4 forces. Some forces are away from the point, and some forces are towards the point. This F1 and F2, they are away from the point, whereas this F3 and F4 are towards the point. We can find out the resultant of these forces, that is Rx and Ry are the support reactions. So we can find out by the condition of equilibrium. Okay, condition of, we can use the condition of equilibrium also. So summation of fx is equals to 0, summation of fy is equals to 0, and as it has been acting at a some distance in the plane, okay, in the body. So here the third concept is also used. That is the summation of movement of all these forces at with respect to some point. Okay, suppose the center is O. So with respect to O, we are finding out the forces on a body with respect to O. So fx is equals to 0, fy is equals to 0, and moment of all forces at a point that is also equal to 0. Okay? So in this way, we can find out by using the condition of equilibrium, we can easily find out the forces along along x and y directions, and the position of the forces with respect to x and with respect to y. We can easily find out the forces. Okay? Here the simple example for this, a 2D rigid body should satisfy the equilibrium conditions. There is small beam is there, a small rollers are provided at the edges, and the distance between these two support A and B is L. If a load W it has been applied at center, so what is the length remaining? L by 2, L by 2, or half is the length. This is simple example is there. As the roller support is there, so how many reactions will be there? So only one vertical reactions will be there. The vertical reactions at Ra is the vertical reaction at the point A, Rb is the vertical reactions at the point B. First we have to find out, first we have to draw the free body diagram for this figure. Second, there is a block which has been moving from point in this plane, this horizontal plane. At the in this horizontal plane, a block it has been moving. The rollers are provided. Okay? So here, in order to resist the motions, vertical reactions at point A will be applied, and vertical reactions at point B will also be applied. Okay? So here we can find out the reaction at support A and the reaction at support B by the simple, that is the condition, by using the simple condition of equilibrium. Okay. So summation of Fy is equals to 0, that is by using the summation of Fy is equal, because vertical forces are there, so Fy is equals to 0, or the moment of all forces at any point. We can take the moment at point A, or we can take the moment at point B by in order to find out the reactions at A and B. Okay. So we can use any point. We can use the moment. We can find out the moment at point A, or we can find out the moment at point B. Okay. So in this way, we have covered the bits, basic things related with the engineering mechanics. In next lectures we will try to cover more things and more basics regarding engineering mechanics. We will try to solve some numericals. We will try to solve some numericals related with 2D or 3D numericals related with the concepts which has been covered in today's lectures. Okay. So if anyone having doubts, or if anyone having queries related with the basics which we have covered in today's lectures, so they can ask the questions related with the basics which we have covered in today's lecture. Okay. So thank you everyone. Thank you. Thank you.